Well, thank you. Thank you very much, Lori, for that very nice introduction. Well, it is a pleasure and an honor for me to be here today among you. This is my first trip to Sweden, to Stockholm, so I'm enjoying every bit of it. Been here a little bit over 24 hours. As you heard, my name is Leroy Chow, and I'm an astronaut. Before becoming an astronaut, in a former life, I was a chemical engineer. I studied chemical engineering first at the University of California at Berkeley, and then I went down to Santa Barbara for my graduate work. And I was working at the Lawrence Livermore National Lab when I put my application in all those years ago and was able to get myself selected. During my 15 years at NASA, I had the good fortune to fly 4 times into space. My first 3 missions were aboard space shuttles, and then on my 4th mission, I got to go train and work with the Russians, flying to the International Space Station aboard a Soyuz spacecraft, where I served as the commander and NASA science officer for 6.5 months. Well, spaceflight really is a magical experience. As you saw from the previous presentation, we're all fascinated with Mars, and Lori and I actually agree that there is no controversy between human spaceflight and unmanned spaceflight, because you really need to do both. You need the Curiosity rover and other vehicles to go out there and explore the terrain to figure out what the environment's going to be before you go and send humans. But there's also a dark side to human spaceflight. We have experienced medical issues during all phases of flight, from launch and ascent, entry and landing, and of course during on-orbit operations. It's really a pretty harsh environment for humans, or for any living system, because we were designed, of course, or evolved to live here in the environment on the Earth. As we started flying longer duration flights aboard the International Space Station, we started to see even more negative effects. I mean, some of these were anticipated, but new problems cropped up that we hadn't anticipated. And as we start venturing further away from the Earth, including going beyond the Earth's magnetosphere, where the radiation environment is going to be much more harsh, we expect to see even more things that we hadn't thought about. One of the things that I do now that I've left NASA, I became very interested in the biomedical effects of human spaceflight, because I myself had lived aboard the space station for 6.5 months. One of the things I do now, I do some work at the National Space Biomedical Research Institute and also the Center for Space Medicine, both of which are part of the Baylor College of Medicine. So we're helping to, figure out what countermeasures we can come up with to counteract some of these negative effects. In fact, the biomedical effects of spaceflight are the technological barrier to sending humans to a place like Mars. It's really not propulsion, computers, navigation, or anything like that. You saw that, as in the last presentation, Lori showed the ellipse, the landing ellipse. I mean, we've gotten pretty good at all those things. It really is figuring out how to keep people healthy that's going to be the limiting factor on when we can send someone to Mars. Well, let me tell you a little bit about myself first and how I got into this business. I grew up during the space race, during the very beginning, or during the Cold War. I followed those early missions with great interest. But it really was the Apollo moon missions which captured my imagination. And I can remember like it was yesterday. Some of you are old enough like me to remember black and white TVs, but I remember watching the black and white TV and the scenes in the Mission Control Center as the lunar module approached the surface of the moon and touched down, and then later watching Neil Armstrong and Buzz Aldrin set the very first human steps on any other planetary body. That kind of sealed the deal for me. So even as an 8-year-old, I knew the world had changed, and I wanted to be a part of it. So fortunately, many years later, after a lot of hard work and studying, I was able to get selected to be a NASA astronaut, and got to go fly my first mission in 1994 aboard Space Shuttle Columbia on STS-65. This flight was it's the second international microgravity lab, and so actually traveled all over the world, mostly to Europe and Japan and Canada, to visit the different people who were doing the principal investigators and learning how to operate the equipment. We had a Spacelab module in the back of the payload bay. Instead of having a satellite or other deployable, this is how we used to do most of the research in space, human intervention, that is. Because these are the days before the International Space Station, and so we had this European-built Spacelab module, and we flew for 2 weeks, and at the time we set a duration record of just about 14 days in space, working around the clock, 2 different shifts, 12 hours on, 12 hours off, and we accomplished over 80 different investigations during this phase. Well, immediately once you get into orbit, of course, the very first time, it's quite an emotional experience, especially because most of us have wanted to do this since we were kids. But getting up there and looking back at the Earth is fantastic. But instantly you start feeling the effects of being in microgravity. Right at main engine cutoff, I mean, you're traveling at you accelerate to a speed of about 17,500 miles an hour to get into orbit. And during the last 3.5 minutes or so of the ascent is speeding up to that speed. So you're under 3 Gs in the shuttle, 3G throttling. That's actually a structural limitation, not so much for the humans, more for the structure that the shuttle used to sit on top of the tank. But so you're under about 3 times the normal gravity that you're feeling, so it takes a little extra effort to breathe, but it's not uncomfortable. But right at main engine cutoff, you're instantly weightless. So what that feels like, it feels like you just did a forward tumble, okay? Your otoliths inside are spinning around, they're sending confusing signals to your brain, and you feel instantly, like you're doing a tumble, and then you're very dizzy. Also, pretty much immediately, you feel the fluid shift. What happens is you no longer have the gravity pulling the fluids down into your lower extremities, so they come up into your chest and into your head, and you'll notice that people look kind of puffy. I was a lot younger then, but you look kind of puffy in space, especially during the first few days. In fact, over the next few days, your body will eliminate 2 liters of water. So you carry 2 liters less water in space. Just imagine one of those big plastic soda bottles. That's how much less water you're carrying when you're in orbit. As I mentioned, you feel very dizzy at first, and this coupled with just being disoriented in the environment can cause some nausea. And so, fortunately, most cases are pretty mild, and we have pretty good pharmaceuticals that can help us cope with this, so really it's not too big of a deal. There are also some more subtle changes that happen to the human body when you're in space. Your immune system seems to change. Your white cell count goes up, your red cell count goes down. We really don't understand why. We're doing a lot of research to figure things like that out. My second mission, I got to go fly aboard Space Shuttle Endeavour. This was a neat deal. I got to go up, and the primary purpose of this mission was to use the robotic arm of the shuttle to go retrieve a Japanese satellite that had been launched 3 months prior. It was loaded up with different scientific samples, or material science samples, to study the effects of the low Earth orbit environment on these different materials to allow us to design and build more robust spacecraft in the future. But the biggest deal for me, personally, it was the first chance I had to put on one of the big white spacesuits and go outside and conduct my first 2 spacewalks. And what we were doing on these spacewalks, we were testing tools and construction techniques that we would later use to go build the International Space Station. Now, going out in a spacewalk, there introduces another set of medical challenges. Most of the flight directors don't really like spacewalks because, as Chris Kraft, the first flight director, used to say, you're just one failure away from killing someone. And not only are you out there and kind of in your own personal spacecraft, being concerned about different failures that might cause you to lose the atmosphere inside your suit, but you're changing pressures. You have to go down to a lower pressure because we're in a pure oxygen environment, and we need the suit to be flexible enough that we can actually work. So you want to get that pressure down. It's a balance. You want to get it as low as practical without imposing other implications on your health. But when you change pressure, of course, there's always the possibility of some barotrauma with your ears or your sinuses. Also, because we're in a pure oxygen environment, or we are in a pure oxygen environment because the pressure is lower, but to get down to that lower pressure, what we have to do is pre-breathe pure oxygen in order to get the nitrogen out of our blood so that we don't suffer from the bends when we go down to lower pressure, just like a diver would if he's down at the bottom diving and comes up too quickly. So there's another set of medical conditions you have to consider. My third mission, I got to go fly aboard Space Shuttle Discovery, and this was a space station assembly flight. So what we did, we went up to the space station, which was pretty small back then. This is in the year 2000. We were only the third construction mission to go up there. We used the robotic arm, and we positioned 2 pieces of the International Space Station that we brought with us in the back of the payload bay. And then over 4 spacewalks, we went out and actually tightened the bolts and mated the electrical connectors to bring those pieces to life. We also installed the high-gain antenna, the Ku-band antenna, this dish here. That's the main data link between the space station and the ground. So all the high data rate things that come down, like video, some of the telemetry, and also data from the experiments all come down through this dish, through the satellite network. Well, after the landing of Space Shuttle Discovery, somehow 10 years had gone by. I'd flown 3 space shuttle missions, and I was trying to figure out what I wanted to do next when the chief of the office asked me to join the Expedition Corps. And this was kind of a change in direction that I hadn't really thought about before. Up to this point, my career had been focused on figuring out how to go build the space station and going out and designing missions and then going out and actually getting to fly some of those missions. Now I was being asked to kind of shift gears. I was still going to be a flyer, but no longer would I be flying those shuttle missions. I would be training to live and work aboard the International Space Station on what turned out to be a 6.5-month flight. So the first thing I had to figure out, of course, was, or wrap my head around, was whether or not I wanted to live in a bunch of tin cans for 6.5 months. That's a pretty big commitment. But actually, the bigger commitment was the training flow. The training flow was going to be at least 3.5 years. I was going to have to spend half of that time in Star City outside of Moscow, because Russia, as the other major partner of the International Space Station program, we had to learn each other's systems. The core module, in fact, the core module where all the major systems, most of the major systems are for life support and thermal control, is a Russian module. And so I had to learn the Russian language pretty much to a fluent level, because I was also going to go fly as a co-pilot on board a Russian Soyuz spacecraft. Now, the Russians had to do the same thing. The cosmonauts all had to learn English because they had to spend half of their time in Houston. But ultimately, of course, I knew I would accept the assignment, and I did. This was my home away from home. This is Star City outside of Moscow. Completely different look and feel than the Johnson Space Center in Houston. Well, some of the major medical categories that we worry about when we go into space, of course, the musculoskeletal effects are important, the cardiovascular. And, of course, the biggest worry that we have is radiation, especially as we talk about missions beyond the Earth's magnetosphere, which protects us from most of the radiation coming from the sun. Well, the International Space Station mission, got through the training and it was time to go fly. We were flying at a time when we were only flying two-person crews. We were flying about 1.5 years after the Space Shuttle Columbia accident, so the Space Shuttle was still grounded. And what we needed to do was to keep crews going to the space station, to keep the station in a good state of repair until we could get the shuttle flying again, because we needed the shuttle to bring up the rest of the big modules, the truss elements, and the solar arrays. And so for a period of time, we were flying two-person crews, because back then, using Russian only with Russian assets, we were only able to support a crew of 2 with the basics, such as, of course, food, water, and oxygen. So the main purpose of our mission was maintaining the station, doing planned repairs and maintenance, as long as fixing things that broke along the way. But, of course, the main purpose the main reason we have an International Space Station is to be the world's premier microgravity laboratory, so we did conduct as many scientific investigations as we could. A special treat, we got to do 2 Russian spacewalks. This was neat for me because I'd become an expert in doing spacewalks using American tools and American suits, and this was a chance to try out the Russian system. We train for spacewalks underwater, same in Russia as we do in the U.S., and basically we get down in the water tank. We have mock-up or modules of the modules that we're going to be working on. We have divers help us put weights in different pockets until we're neutrally buoyant, and we can just actually go through and practice everything that we're going to do on a 6.5-hour spacewalk. I also got to fly aboard the Russian Soyuz, as I mentioned. This was also a treat, having flown on three space shuttles. This was a neat experience to get to go fly on in the Soyuz. You can see you're pretty cramped in there. This is a simulator, but you can see you're pretty cramped in there. The shuttle was positively luxurious. It was definitely business class seating. You could stretch your legs out, stretch your arms out. This is definitely super economy. You've got to want it. Well, this is the crew that flew aboard Soyuz TMA-5. Salojan and I over on the left, Yuri Shargin on the right. Yuri was flying his first flight into space. He didn't spend the 6.5 months with us. We spent about 10 days doing a handover with the Expedition 9 crew, and then he came back down to Earth with them. Well, something I hadn't thought about. I've traveled internationally, most of my life, and really do enjoy it a lot. But something I hadn't thought about was actually during this whole 3.5 years when I was going back and forth to Russia, I really became immersed in the culture to the point where when I landed in Moscow, I would start thinking like a Russian, and I would start doing things their way. And it really was a very enriching experience. And something I hadn't really thought about was how it really changed my perspective on a lot of things. Even though I traveled a lot before, actually living in a different country really helps to change, I think it expands your horizons. So just as an aside to you young people, if you ever do have the chance to do a study abroad program, or in your work, if you have an opportunity for a detached assignment overseas or in another country, I would encourage you to go do it, because I think you'll find that it really does help you quite a bit. One of the neat things that the Russian program has that somehow NASA does not, there's a lot of tradition and superstition in the Russian program, which I enjoyed learning about. One of them is 2 weeks before launch, we finished all of our final exams, and we go down to Red Square, and we lay flowers at the graves of some of the greats of the Soviet space program, including Sergei Korolev, the father of the program, as well as Yuri Gagarin, the first person ever to fly into space. We also went inside the Kremlin wall to touch this tree. This is the Gagarin tree. This was planted in honor of Yuri Gagarin in 1961 after he made the very first space flight. And since then, every crew that has launched from the Baikonur Cosmodrome has come to touch this tree for good luck before going off on their missions. Well, then it was time to go down to Kazakhstan. We got on this knockoff of a 727, flew down to Baikonur, which is located east of the Aral Sea. Baikonur looks a lot like West Texas, both on the ground, from the air, and from space. It looks a lot like West Texas. It's the perfect place to launch and recover spacecraft because there's nothing out there to hit. Well, we checked everything out, including our space suits. Each pressure suit is custom made for each individual, so we had to make sure those were all in good shape. And then it was time to go to the rocket 2 weeks later. We checked everything out, and then went out very early in the morning, about 3 o'clock in the morning. This is what the vehicle looks like. We went up to the top of the rocket, got ourselves strapped in. There's a KGB guy taking us to the top. He never said a word, but they probably always had a KGB guy. I don't know. It's one of the traditions they haven't gotten rid of. Anyway, we said our goodbyes, got up to the top of the rocket, got strapped in. Now, this is kind of interesting. This is the launch bunker is dug into the ground only about 50 meters away from the launch pad. And I don't know why it was so close. Maybe when they built the Cosmodrome, they had a shortage of copper wire or something. But all the rockets that I had known of are launched by computer control. In fact, the space shuttle used to launch itself. At T-minus 31 seconds, control would revert from the Launch Control Center into the vehicle itself, and the main computers would take over aboard the shuttle. At T-minus 6.5 seconds, it would send commands to the 3 main engines to light. It would assess their performance, and if everything looked good at T0, it would go ahead and issue the commands to light the 2 solid rocket boosters, and you were on your way. In this case, a launch officer actually puts that key in there and turns it to launch our rocket. So you want to make sure that he set his watch correctly that day so we get into the right orbital plane so that we can go find that International Space Station. Fortunately, he did. It takes a little over 9 minutes to get from the launch pad up into low Earth orbit. So we flew around for 2 days autonomously in our Soyuz, phasing our orbit to match that of the International Space Station before we could come up and approach and rendezvous and dock. Once we got on board, we spent about 9 days with the Expedition 9 crew before getting them on their way home. Put our patch, we were the 10th expedition to the International Space Station, so we put our sticker up on the wall in line. Set up our work areas, just like you might here on Earth. Set up some pictures, set your computer up the way you like it. Salajan unpacked some of the friends he brought along with him. It's going to be a long mission after all. And we began our 6.5 months in space. Well, as I mentioned, the main purpose of our mission was maintenance, so we did a lot of maintenance work. But of course, the main purpose of the station is to do scientific investigation. So we did have as robust of a science program as we could, with the limitation that we didn't have a space shuttle to bring up large amounts of supplies and bring back samples and also bring up new experiment racks and new experiment apparatus and all that. Exercise is a very important part of being in space. During the program of being on the space station, we're scheduled for 2 hours of exercise every day. And we find that mitigates a lot of the negative effects of being in space. Now, if you think about being in space, if you're not exercising and you're just floating around, it's kind of like laying in bed here on Earth. In fact, that's why we do bed rest studies, because we're trying to simulate the space environment to study, to develop these countermeasures that we might be able to use to lessen the need for exercise or other things. But if you're not exercising and you're laying in bed here on Earth, you would quickly get out of shape. I mean, just imagine laying in bed for months at a time and then trying to get up and walk. You probably wouldn't even be able to do that. But if you got out of bed every day and you exercised for 2 hours and got back into bed, you'd probably be okay. So it's kind of the same idea. We We have different devices to help us exercise. You saw the exercise bike here. Here's the treadmill. Of course, on the treadmill on the station, you need a harness and rubber bungees to hold you down to the track. Otherwise, you just float away. We have a resistance exercise device, and that helps us to keep our muscle mass up and also to keep our bones in shape. Now, one of the things that we've seen in the last several years that is still perplexing to us is we started noticing some astronauts came back and started complaining about changes in their visual acuity. You may have seen this in the news over the last couple of years, but some astronauts started complaining that their eyesight seemed to be affected during this long-duration flights. And so when they came back, we were able to measure that they seemed to have elevated intracranial pressure. Okay, the pressure inside of their head was higher than it should be, and that was actually directly seems to be affecting the retina, and we're seeing all kinds of anomalies in the retina, and it's starting to, this has become the biggest problem that we face right now is figuring out what's going on. Because right now, with the data that we've collected over the last several years, fully 50% of the astronauts who go fly long-duration flights have come back with some effect of this elevated intracranial pressure. So we're not trying to figure out first, and of course, we want to understand what's causing this. We want to understand how to prevent it and then how to treat it. Now, unfortunately, in the intervening years, we've been doing a lot of research, but we really haven't gotten that far on figuring out what caused this. We have some ideas, but we have not found a smoking gun per se. Now, the first case came, or several of the cases started appearing after we sent our newer exercise device up there called the Advanced Resistive Exercise Device. The one that you saw me using is relatively low loaded. That is, you can't put that much resistance on it because it's physically, much smaller and less capable. So we compensated for that by doing more repetitions, more sets of exercise, which takes more time. So they developed this pneumatic device that can actually load you up pretty heavy. It's about, somewhere around 250 kilograms worth of weight, equivalent weight, and you can do these extremely high weight load-bearing exercises to try to keep your hips in shape and things like that. So we're wondering if maybe that might be part of the problem, because when you're doing weightlifting, even on Earth, your intracranial pressure goes up, but of course once you stop the exercise it returns to the normal level. So even if this is contributing, it's still puzzling why the pressure doesn't equalize back down to a normal pressure once you stop doing the exercise. We also looked at the food. Now the food is very high in sodium, very high in salt, and part of the problem is that the requirements were a lot of the food items we use, they come from the military. They're meals ready to eat from the military. And the requirements, if you think about the requirements for food, it's totally different for a warfighter than astronauts floating around on a space station. Right? If you're a warfighter, you're under stress, you're physically very active, you're getting shot at, you're sweating a lot, and so you need a lot of calories and you need a lot of salt. And that's what this food is full of. But if you're a sedentary astronaut sitting on board the International Space Station, sedentary except for the exercise periods, this is totally the wrong kind of food. So the elevated sodium could also be playing a role in this. One of the neatest experiments that I was involved in was the advanced diagnostics using ultrasound and microgravity. Scott Dolchowski, looking over my shoulder during a training session, was the principal investigator. He's the chief surgeon over at the Henry Ford Health System over in Detroit. And he had the idea of using what we had on board, an ultrasound, as a diagnostic tool. Of course, an MRI machine or a CAT scan, that's what you use on the Earth. That's the gold standard on the Earth for imaging and doing medical diagnostics. But of course, those devices would be much too heavy and much too power intensive to bring up to the space station. So using the ultrasound device that we had on board, he was able to actually pioneer these different techniques that allow us to do quite a bit of diagnostics using an ultrasound that had not previously been done. Now, the neatest thing about this was that neither Salanjan nor I were medical doctors or any kind of sonographers at all, but even with just literally a few hours of training, we were able to recognize a good ultrasound image from a bad ultrasound image, and we were able to learn the way to do remote diagnostics, where a doctor and the team were on the ground talking to us, getting the images that we were getting on each other, and we were able to produce diagnostic quality images from orbit on each other's internal organs, bones, teeth, and even eyes. Here I am doing the first ocular exam in space. This was kind of a neat thing, and we actually published a paper. Dr. Dolchowski had us send down the paper from orbit, and we actually got it published, so that was kind of a neat thing. But the ocular exam at the time, we were thinking, this was before we knew about the vision problems, we were thinking it would be useful in case you had some particle get in somebody's eye. You're thinking about some kind of an eye trauma and using this device to kind of do a diagnosis to see if there was a foreign object in the, somewhere in the eye. But as it turns out, it became very useful for looking at or measuring, indirectly measuring the intracranial pressure inside of the head. It turns out that the optical nerve sheath diameter varies with the pressure, and so now every astronaut is scanned on the ground to get a baseline measurement of the diameter of their optical nerve sheath, and then periodically during their mission aboard the International Space Station, they're given this ocular exam to see if that diameter is changing to indirectly measure the fluid pressure inside of their skull. The neatest part about this experiment is not only will we use this technique as we go longer and farther into space for telemedicine, but Dr. Lechovsky and his team have actually deployed this on the ground through a United Nations program. They have teams in Central America. They've had teams over in Madagascar and different parts of Africa, and they're actually able to use technology developed here on Earth to allow him to actually use very rudimentary internet connections, even through the mobile phone system, to be able to send images back to his hospital in Detroit from the field. Ultrasound machines now are very small. They're smaller even than laptop. They're kind of laptop size, but you can get even smaller ones. And then with these other pieces of equipment, you can actually transmit these data back through in near real time to Detroit or any other hospital. And he's demonstrated that this is really helpful in developing worlds, especially for expecting mothers who are having some issues with their pregnancies. They can do a scan in the field to get the results back to an expert who can say either make a determination, either, hey, there's nothing, this looks fine, there's nothing to worry about, or this could be an issue, it's time to make that start making that 3-day trip to the hospital. Well, of course, radiation is still the biggest thing biomedically that we worry about when we talk about sending astronauts farther, either to the moon for an extended stay or to the eventually to the surface of Mars. An obvious thing would be to shield. Turns out this is not such an easy problem. Of course, shielding can be very heavy. If you send up a bunch of lead bricks, I'm not sure what the current rate is for launching things, but it's always been somewhere around $20,000 or $30,000 per pound to launch something into space. But it also turns out, of course, to be a difficult problem because if you send something like a high Z material up there and you have high energy radiation strike it, you can actually get worse radiation off as a secondary radiation. That is, the Bremsstrahlung radiation comes off in a form of radiation that's more dangerous to living systems than the high energy particles. Say a gamma ray has a relatively low cross-section for the human body. We actually do shield part of the International Space Station. The aluminum hull does help out a fair amount, but inside of the sleep stations we do have some polyethylene bricks. Other people will take, this is what it looks like inside. These were my home. This was my home, I guess, on the International Space Station. But other people have taken water bags. Those white bags are filled with water, and they've lined, put additional shielding inside of the sleep station with the water to try to slow down some of the protons that are coming through. And this, of course, is an old picture. We now know that there are actually 3 Van Allen belts rather than 2. But, the Van Allen belts and the magnetosphere, they help trap a lot of the radiation that come from the sun, so that's why we're relatively protected here on Earth. So there's been ideas. Can we create our own Van Allen belts? Can we use energy to create our own magnetic fields to trap this radiation? That's an interesting idea. I'm not sure that it would really work on a practical level because of the power requirements. We would definitely need something like a nuclear reactor to generate enough power to do something like this. But in itself, you've got to now think about, okay, what effect are these electric and magnetic fields, what effect are they having on the health of the astronauts inside? You may actually be creating a bigger problem than you're trying to solve. We've put a lot of money into detection. Of course, detecting radiation is important. But as far as treatment, this is pretty much the state of the art, the big green vitamin pill. So I took one of these every day on board the station. I'd have it in the morning with my breakfast. It would sit right about here. So drinking coffee and everything else kind of right around lunchtime, maybe it's made its way down. But this is a commercial off-the-shelf vitamin, and it supposedly was going to go clean up all those free radicals and everything, but I think it was mostly to make me feel better. The psychosocial factors of exploration cannot be understated, especially if you're talking about sending a crew to Mars. It's going to be a weird thing for a crew to start looking back at the Earth and watching it getting smaller and smaller until it becomes a star, and the time delay for the communications at the speed of light turn into minutes, rather than the fractions of a second. This, of course, is one of the Robert Falcon Scott's expedition to the South Pole. This was on the way back, the photograph taken on the way back, and unfortunately, of course, this team perished. They weren't able to make it back from their mission. But you can see on their faces the stress that they had been under and the extreme conditions. Certainly in spaceflight, we've had our share of some of these experiences. The Russians have been flying long-duration missions a lot longer than we have, and early in their program, they learned the importance of things like selecting the right crews to go together. On Salyut stations and on Mir space stations, they've had very serious issues where tensions have escalated to the point where at least 2 times they've had to end missions early, actually bring the crews down because they were literally ready to kill each other. I mean, in the shuttle program, we flew 2-week missions. And so for 2 weeks, pretty much anyone can get along with anyone and you can make anything work. But you put people together for, 6 months in a confined space, you'd better make sure that you do your selections properly. Depression has also been an issue. There, at least on one occasion, a cosmonaut actually, admitted later after the mission that things had gotten so bad that he had actually considered committing suicide while in space. And, fortunately decided not to, but it can get pretty serious. So we study some of these, we study different expeditions on Earth to try to learn something, to apply to space flight. So we look at analogs, including analogs at the South Pole, up at the north, near the Arctic Circle at the Houghton Mars Project up in Devon Island. Food, of course, is a big deal, and you submariners know about how important food is. That's why the best food goes to the guys who go down in subs for months at a time. On our flights, we actually, you all have been there. Had a lousy day, you've had a bad day. If somebody's prepared you a nice meal, or you go somewhere and have a nice meal, it sure helps to perk you up and make you feel a lot better. And so food is just as important in space. Of course, this is the food we have. It doesn't look nearly as good as the pictures I just showed, but still, you start to look forward to it. And in fact, it's interesting. One of the things that I thought about was, of course, on a shuttle mission, you eat this, like I said, for 2 weeks. So what? You can do this. It's like backpacking. But something happens because it's important to keep your weight up in space, to eat and keep your weight up so that you can, for health reasons. But I wondered if I would be able to eat this food and for months at a time and not lose a lot of weight. But something interesting happened after about 3 weeks. I think your mind plays a trick on you. You know that you need to eat to stay healthy, and so your mind somehow makes this food suddenly seem very delicious, and you start looking forward to it. Of course, once you get back on Earth, you have real food again. You know how wrong you were. But on our mission, we actually had a food shortage. Our buddies on Expedition 9 had gotten into our food. They tell me someday I'll laugh about it. But we actually had to ration food for about 4 weeks. We were eating about 1,000 calories a day of real food. They left us plenty of sweets, plenty of desserts. Maybe that's good if you're a kid. And if we got really hungry, we could eat a candy bar or something. But it was not very pleasant. We each lost between 5 and 10 pounds and, kind of got through that. But that kind of shows you the importance of food. It's something that you've really got to keep your crew full of. But we spent the holidays in space, and it was very special, not just because we were in space, but on Christmas Day, the resupply ship arrived, so we were pretty happy about that. Not only were we running low on food, we were running low on water, and had this ship failed to dock, then we would have had to evacuate the station. We quickly regained the weight that we had lost. As you can see, the food is not particularly appetizing looking, but like I said, after several weeks, it suddenly starts to seem pretty good. We got some treats, including Russian chocolates, and also Russian honey and tea. That bag is filled with tea, and the toothpaste tube thing is filled with Russian honey. It's a nice combination. This is what happens when you spill something in space. It forms a ball, it floats around, and you can play around with it, but you better drink it up before it hits a panel and makes a mess. Here's Saljan making one of those water balls. This gives you an idea of the interior volume of the station modules. It's actually pretty big. The station, when I was there, was only about half the size that it is now, but there were only a crew of 2 of us. So it felt subjectively like about the size of a good-sized 3-bedroom apartment. So we really had plenty of room to not get in each other's way. And as you can see, it's not at all like the Soyuz spacecraft. There's plenty of room inside. Now that we're flying a crew of 6, of course, there's always a crew of 6 on board. But the station has also doubled its interior volume. So the crews that I've talked to still say it's plenty big enough. Well, doing EVAs or spacewalks was an exciting highlight of the space station. It was exciting for Salishan because he had never done spacewalks. It was exciting for me because it was my first chance to do spacewalks using a Russian suit. What we were doing, we were installing experiment packages, including a remote robotics experiment, as well as retrieving samples that had been left outside by previous crews. We also furthered construction of the space station by installing navigation antennas that were used by the European Space Agency's automated transfer vehicle, which is a cargo ship. And we also launched a nanosat, which was a little coffee can-sized satellite that Salishan just threw off the back of the space station. Educational outreach is a big part of what we do at NASA, and so we did have organized teleconferences with different schools, but we found a very efficient way to reach a lot of students was using a commercial ham radio, and we actually set a record during our mission, which has since been broken, but at that time we made 26 contacts with schools from around the world, and for 10 minutes as we flew from horizon to horizon, the students were able to ask us questions about space. Well, the best part about being in low Earth orbit is looking back at the Earth and taking photographs. People often ask, well, what did you do up there? Did you get bored? Well, you never get bored. First of all, you're kept pretty busy, and they want to know, well, did you have, movies and all that? Yeah, we have DVDs, and we have some electronic books they can send us, but anytime we had free time, we were looking out the window and taking photographs. In fact, on this mission alone, I shot over 16,000 photographs of the Earth. So I'll just share a few of them with you. Here we are looking over the Himalaya Mountains into China. And from our perch from about 250 miles up, the Himalayas down on the bottom, they look pretty small, but just remember buried down in there somewhere is Mount Everest. This is what's possible on a clear day with a little bit of practice. This is downtown Houston using the long lens. Astronauts are able to get pretty clear pictures. Now, it's a little bit more difficult than you think taking pictures from space because you're traveling at 17,500 miles an hour, which works out to almost 5 miles every second. And so you can't just put the camera in the window and shoot. You've got to pan your target, find and pan keep your target and pan it as you release the shutter. You've also got to be focusing. You have to, even from that extreme distance, you can't just slam the focus over to infinity. It'll still be blurry. So you've got to focus, and then you've got to release the shutter. By the way, you're weightless, and so you've got to use your feet to hold on to something. Otherwise, you're going to float away from the window. But with a little bit of practice, you can get pretty good at it. Here's some different places from around the world. This is Kabul, the capital of Afghanistan. This is Mecca, Saudi Arabia, and the white spot in the middle, that's the Grand Mosque. This is Beijing, the capital of China. The rectangle in the middle is the Forbidden City where the old emperors used to live. This is Seoul, South Korea at night. And, one of the cliches that sometimes people say is, from space you can't see borders, you can't see countries. But that's not true. Actually, you can see a lot of borders, and North and South Korea at night was one of the most stark differences. The south is brightly lit. You can clearly see the border, and everything south of the border is brightly lit. And then up north of the border, it's totally black, completely blacked out. Even Pyongyang, the capital, there are no lights that I could see coming from the north at all. This is Tripoli, Libya. New Orleans, this is taken in 2004, so this is before the hurricane. Manhattan, New York. You can clearly see the Central Park, of course, skyscrapers. You can see boat wakes in the east and the Hudson Rivers. This is Moscow. You can see the ring roads around Moscow, around the Kremlin, Moscow River snaking through the city. This is a large lake in central China. This is Qinghaihu, and I want you to look at the mountains on the left, and then beyond the mountains is the Gobi Desert, and over there is the Jiuquan launch site, and from there China in 2003 became only the 3rd nation able to launch astronauts of their own. Here's a close-up of the Himalayas. This is Cape Cod. Finger Lakes. This is the southern tip of Florida. This is a very beautiful part of the world. The blues and greens are just spectacular. In fact, none of these pictures have been artificially colorized or enhanced or anything like that. This is what it really looked like looking out the window. And these are the raw data files that I brought back with me. Here are glaciers in Patagonia, South America. You see the Great Pyramids? It took me literally about 3 months to find these pyramids, but once I did, I could pick them out with the naked eye. This is the island of Sumatra. This is, you remember in the end of 2004, we had a tsunami 2 weeks after the fact. The clouds parted enough that I was able to take some of these photographs, and you can see how big that wall of water must have been. It's almost unimaginable to think about that water that went all the way up the mountainside and washed all those trees away.
Maybe if we could wrap up because we want some time for questions.
Right. Yeah. Sometimes Mother Nature's just funny. I saw this out the window at the end of January that year, and I grabbed a camera, and the perfect thing to send to my wife for Valentine's Day. Of course, it's been hard to top since then. Yeah, here's some kind of more artistic views. This is part of the Egyptian desert. Here's an area in the Ukraine. I'm not sure what those Ukrainians were up to, but this is about the most unnatural green you can imagine. Being a chemical engineer, I can figure that's probably some kind of a copper solution, an evaporative recovery pond. No doubt an environmental disaster, but it made for a pretty picture. Here's an area of the Sahara Desert in Algeria. This is one of my favorites. This is Lake Nasser, catching the reflection of the sunlight perfectly off the surface of the water into the camera lens. Well, 6.5 months were coming to an end, so it was time to start getting ready to come back down. The Russian Mission Control Center asked us to put our suits on to make sure they still fit, which we had a good laugh about because what were we going to do if they didn't fit? We were still going to come back. But the reason they asked that is because in space you actually grow about 1 inch to 1.5 inches because your spine relaxes, and so they have to accommodate for that when they build your suit. Well, this is what it looks like coming down, where the crew compartment is the little dot down there. This is the Expedition 9 crew that I shot this photo with as they streaked by underneath the space station looking straight down. The other two pieces are modules that have separated and they're burning up in the air friction as they slow down. We landed with a big thump on the steppes of Kazakhstan. All the shock-absorbing systems worked, so we hit really hard, but it didn't hurt. As sometimes happens, we tipped over. But the rescue forces were right on top of us and had us out in about 15 minutes. They got us out, put us up in lawn chairs, gave us satellite phones so we could call our families, tell them we were down and safe. After a quick ceremony in Kazakhstan, we got back on the airplane, went out to Star City, back to Star City, reunited with our families and our loved ones. And finally, this is the picture I want to leave you with. This, of course, is a picture of the moon. I shot this from the station using the long lens, and it was the moon that inspired me to want to become an astronaut myself. Mother Earth, the home planet on the left, and the blue in the middle is kind of what I want to bring your attention to. This blue doesn't show up very well even on this photograph. It's very difficult to capture this in photographs because it usually gets washed out from the reflection of the sunlight off the surface of the clouds. But really, it's the most startling thing that I saw when I first got into space was just how bright that blue is. It's caused by the sunlight going through the Earth's atmosphere, causing it to fluoresce all these different shades of blue. But this to me says dreams, and this is what it's really all about, and especially for the young people here. It's about going out and figuring out what it is you'd like to do and going and making it happen. And I think you, just like I enjoyed the last presentation by Lori, it's about getting out there and finding out what's going on. So I want to encourage all of you, everyone, to really think about what you'd like to do, especially the younger folks here, because you really can make it happen and you can make a difference. So thank you very much.
Thank you.